Today we are going to discuss an important topic, that is block diagram reduction. Using this block diagram reduction technique, we are actually going to find the transfer function of a system. So first, let's see what is a block diagram. Block diagram is basically a pictorial representation of functions performed by each component in the system. It also indicates the flow of signals. It will indicate the direction in which the signal flows. If you look at the block diagram, we can see three main elements in a block diagram, and the three elements are block, branch point and summing point. Okay, so block means it's actually a symbol for the mathematical operation on the input signal. Okay, see, for example, this one. So this is the block. In that block we actually represent the gain of the system or transfer function of the system. Sometimes you can see that transfer function or gain in represented in S domain, for example g of s, or you can see it represented as simply g. Now to that particular block we are giving an input signal A. Then what would be the output of this particular block? So what happens to this signal A? This signal A, as it passes through this block having a gain G or G of S, this A will get multiplied with G, and this block will produce the output A into G or A into G of S. So this would be the output. Okay. So in simple sense, you can consider this transfer function of the as the gain itself. Okay. So that is the block. Then we may be having branch points in the given system. So branch point means it's a point from where we are taking the signal and we are providing it to some other branches. So that's a branch point. See, if you look at this particular diagram, you can see a branch point over here. This branch is actually taken from a point where we apply this signal A. Okay, so through that particular branch we will be getting this signal A itself. And here in the forward path we are having a system with the gain G or a system with transfer function G. So the output of this particular block would be A into G. Suppose I am taking this branch point from this. Instead of this branch point, I am taking a branch point from this point. I am fixing a branch point at the output of this G block. Then what would be the signal that flows through that particular branch if my branch point is over here? If the branch point is here, then the signal that will pass through that particular branch will be A into G itself, because I am taking the branch from the output of block G. So whatever signal that comes at the output of block G will pass through that particular branch. Okay, so the output signal that we get at the output of block G will be this A into G. Okay, so that's a branch point. Then we can also see a summing point. Summing points are basically used to add two or more signals. The symbol that we use is like a circle with a cross, and inside that we will mark the sign also. So plus here means this A is plus, positive, and here you can see at the bottom part signal B is applied where it's denoted as minus. That means this B is minus B. So the output of this summing point, what the summing point will do is it will add these two signals. So when you add these two signals, you have to take care of the sign. So A plus, this is plus A minus B. So A minus B is the output of this summing point. Okay. So this B is actually considered as some kind of feedback signal. It's not necessary, but we can also consider this as something like a feedback signal. Now we are moving on to the block diagram reduction technique. This block diagram reduction is actually carried out to find the overall transfer function of a system. Suppose we are having a very big system that consists a large number of blocks, and we want to find the overall transfer function of the system. Okay, for that what we will do is we will try to reduce that particular large system to simpler and simpler systems. So we will try to reduce a large system to simpler ones, and ultimately we will find the overall transfer function. So for doing that, we need to have almost 11 rules so that are applied to this block diagram reduction technique. So you should know which all are the 10 to 11 rules and how we can apply these rules. Okay, so we shall move on to the rules. First, rule 1, combining blocks in cascade. Suppose we are having a system like this. We are having two blocks in series. Cascade means series connection. So one block is with gain G1 and the second one is with gain G2. Okay, so I am applying an input A. So A, when applied to a block with gain G1, will get a signal AG1, and this AG1 is going to the block with gain G2. If so, what would be the output of G2? This AG1 will get multiplied with G2 and we will get AG1 G2 at the output. Okay, so now what I am trying to do is I am trying to combine these two blocks into a single block. Okay, so when you do that kind of reduction, the input output relationship should not change. That means even after you are doing the reduction, the input would be A and the output should be AG1 G2. If that is the case, then how can you reduce these two blocks into a single one? As I told, the input output relationship should not change, so our input should be A, because here also our input is A, and after reduction the final output should be AG1 G2, because in our original system the final output is AG1 G2. So the input is A, output is AG1 G2, right? So what should be the transfer function, or what should be the gain of the system that we have here? So we are combining these two blocks into a single one. So here we will be having a single block. To that single block, A is the input and the output from that block is AG1 G2. Then what should be the gain of this block? It should be G1 G2. So signal A coming to a block with the gain G1 G2. What will happen? This signal A will get multiplied with G1 G2 and will produce the output AG1 G2. So if we are having blocks in series or cascade, it can be converted into a single block, and the gain of that particular block will be the product of two individual gains, right? Okay, fine. Moving on to rule 2, combining parallel blocks or feed forward paths. You have to be very careful when dealing with the feedback and feed forward. Feedback means you have to look at the direction of the signal. Okay, you have to look at the arrow mark. Feedback means the signal will be traveling from the output side back to the input side. Okay, so that is feedback. If the signal is moving from input side to the output side, then it is feed forward. See, if you look here, you can see A is the input. I am having, see, two blocks in parallel, one with the gain G1 and the other one with the gain G2. The same signal A is provided to G1 as well as G2. So signal A coming to G1 will produce a signal AG1. This A will get multiplied with the gain G1 and will produce AG1. Similarly, the signal A coming to G2. This A will get multiplied with the gain G2 and this will produce AG2. So here we have AG1 and here we have signal AG2. These two signals are then provided to a summing point. And here at the summing point, the two signals are having sign plus plus. So these two signals will get summed up, right? So why I am saying this is a feed forward? See, look at the direction in which signal flows. This is from input side to output side. If the signal was from this output side back to the input side, then it would be a feedback. But this is a feed forward. Okay, so always look at the direction. Look at the arrow mark or arrowhead, the direction in which signal flows. So that actually determines whether it's a feedback or feed forward. So as I told, here we are having a summing point to which we have signals AG1 and AG2. So these two signals will get added up and will get AG1 plus AG2. So A into G1 plus G2. Right. So here also what I am trying to do is, here we have two different blocks, each with gain G1 and G2. So I am trying to reduce this system to a simple system with one block. So if that is the case, then what would be the gain of that single block? So please remember, when we try to reduce the system, the input output relationship should not change. That means after reduction also the input should be A and the output should be A into G1 plus G2. So instead of these two blocks, I am just drawing a single block over here. To that single block, our input should be A itself and the output should be A into G1 plus G2. So from signal A, how to get this A into G1 plus G2? From signal A, we will get A into G1 plus G2 if the signal A passes through a block having gain G1 plus G2. Right? So the gain of this particular block or system will be G1 plus G2. So this A will get multiplied with G1 plus G2 and finally we'll get the output A into G1 plus G2, which is the output in our initial system. Okay. So rule 2 says that if we are having this kind of parallel blocks or feed forward paths with gain say G1 and the other one with the gain G2, this can be reduced to a single block and the gain of that single block will be the sum of the individual blocks. So G1 plus G2. Okay. So keep in mind the difference between cascading and this parallel blocks. Okay. So cascading means we are having different blocks in series. In that case, if we are trying to reduce, then the final gain or the overall gain of the system will be the product of the individual gains. Clear? But if we are having two blocks in parallel, then the overall gain will be the sum of the individual gains. Okay. So rule 3, moving a branch point ahead of the block. So this is our actual system. We have signal A, we have a block with the gain G. Signal A is applied to G, and this block G will produce the output AG. Okay. Here I am taking a branch from this point. So this point is the point where we are applying this signal A. So in this branch we would be getting signal A itself. Right. Now I am going to apply rule 3. That means I am going to move this branch point in front of G, ahead of G. So what should be the change that is to be made? Okay. So we have the same signal A, we have a block with gain G, and we'll get output AG. The change I have made is I have shifted this branch point from here to this point. So now my branch point is over here, right? And the signal that I should get from this branch point should be A itself. This is the signal I should get. But right now, after shifting the branch point, what I get from this point is, so now this point is at the output of block G. So obviously the signal that we get over here will be this A into G. But actually what should I get? I should get A. So now I will think how to get the actual signal A from AG. To get signal A from AG, the signal AG should pass through a block with the gain 1 by G. So what will happen if AG passes through 1 by G? This AG will get multiplied with 1 by G. So AG into 1 by G, G will get cancelled, and the signal we ultimately get will be A itself. So this is the modification that we have to make while shifting a branch point ahead of the block or in front of the block. Okay. So maybe in your question, this instead of this G, it may be say G3, or it may be G2, G3. So likewise. So based on that, you have to make the appropriate changes over here. Okay. So this 1 by G has come here just because the gain in this block is G. If this is something else, based on that we have to make the necessary changes over here also. Okay. Now rule 4, moving a branch point before the block, right? So here we have a block with gain G. We are applying signal A to the block, and at the output we have AG. So in this case our branch point is at the output of G. This is the branch point. So from that point I am taking the signal. So what I get here will be AG, right? So now what I am trying to do is I am trying to shift this branch point before the block G. So from the front side of block G, I am trying to shift this point to the back side of G. So what should be the change that I have to make in the branch? Let's see. So here we have a block G. I am applying A, and we will get AG. Right? So my branch point was actually here. So now I have shifted that branch point to this point. So even if I shift this branch point, the signal that I should get here is AG. This is the thing I need there. But here, after shifting the branch point this area, the signal that I get here will be A only, right? But what I really need is AG. From A, how to get our actual AG signal? From A, in order to get AG, this signal A should pass through a block with the gain G, like this. So in that branching, I have placed another block with the gain G. To that block we apply the signal A. So this A will get multiplied with the G, and finally we will get AG in the branch. Clear?